Alright, today we are looking at using the rational root theorem to find zeros of a polynomial function. A rational root theorem to find zeros of a polynomial function. We've been finding zeros, but today we're getting into polynomial functions that require a little bit something different to find the zeros. So far, when we're finding zeros of a polynomial function, what have we done? Speak up, I can't hear you.
Factored and set to 0.
We've factored and we've set it equal to 0. So today we're going to be looking at polynomial functions that we cannot factor. The exponents are too high and we can't factor them, so we need another method to be able to get to the zeros, and that's where the rational root theorem comes into play. So let's say I've got f of x equals x to the fourth plus 3x cubed minus 7x squared plus 9x minus 30. So here's my polynomial function that I want to find the zeros of. First of all, how many possible zeros are there?
4.
There are 4 possible zeros. Why are there 4?
There's 4.
That's the highest exponent. Okay? But we're going to use the rational root theorem. So we need to talk about the word rational. What does the word rational mean to you?
Logical.
Real.
Makes sense.
Okay, rational numbers are real numbers.
Something you can
Yes,
grasp.
Max.
Something you can grasp.
Alright, but let's get mathematical in terms. With rational numbers, what particular numbers are we talking about? Natasha?
Can we set
There you go. Anything that can be written as a fraction is considered a rational number. Okay? Anything that can be written as a fraction. Okay? So, does that mean 2 is a rational number? Yes, because how can it be written as a fraction? 2 over 1. So if it can be written as a fraction, we're talking about a rational number. So we're interested in finding rational zeros using the rational root theorem. Here's what it says. So I've got 4 possible zeros. It says if this thing has rational roots, those possible zeros have to be factors of my last term. So that means I'm dealing with 1, 2, 3, 5, 6, 7, 8, 9, no, 10, 15, and 30. Okay, and it's not just the positives, it can also be the negatives of those. Okay. So if this thing has rational zeros, it's going to have to be one of those numbers plus or minus. Okay? So, what can I do to figure out which one of those numbers work? I can plug them in, but that's going to take me a while. What can I do that might be a little bit quicker? Synthetic division and, right, but how can synthetic division tell me whether or not they're factors?
the root theorem thing? The theorem?
Yeah, it's on
Remainder
the
theorem?
it's on the last one.
What about the remainder? There you go. If I don't have a remainder, if I divide using synthetic division and I don't get a remainder, that tells me whatever I'm dividing by is a 0. Okay? So the rational root theorem gives me my possible rational roots, then I have to use synthetic division to figure out which ones are. Okay? So, we're going to set it up. So I've got 1, 3, negative 7, 9, and negative 30. So of those numbers over there, which one do you want to give a shot? And remember, it can be plus or minus of any of those numbers over there. So what do you guys think? 1? Alright, let's try 1. So 1, 1, 4, 4, negative 3, negative 3, 6, and 6. Does 1 work? No. Keep track of what does not work. So over here on the side, I'm going to put a 1, and I'm going to say that 1 does not work.
Wait, so we have to do 18 times.
Surely the
We do not have to do all of them. Because how many work?
4.
Only 4, possibly. It might be less than that. Okay? But a maximum of 4 work.
But for unlucky.
If you're unlucky, yes, it's going to take a while.
Okay.
But you'll see that in this case, I only need to find 2. Once I find 2, I can find the last 2 real quick. You'll see why. What else do you want to try? 2? So 1, 2, 5, 10, 3, 6, 15, 30, and I get a 0. So that means 2 is a 0.
Does that mean negative 2 is also
Does not mean negative 2 is also 0. Here's the nice thing about once you find one. Okay, I am no longer concerned with 30. I am now concerned with
15.
I'm concerned with 15 because I now have a new polynomial function that is just made up of these 4. Okay? So once I get it down, now I'm only dealing with 15, so that means I can go in here, eliminate 30, I can eliminate 10, I can eliminate 6, and I can eliminate 2. Yeah, we already did 1, but it might be negative 1. We haven't tried negative 1 yet, so it could be negative 1, so I can't mark that one out yet. All right? So, let's go again. What do we want to try now? 3? Now, I can tell you right now, 3 is not going to work. Can somebody tell me why I can look at it right now and tell that 3 is not going to work? What do you notice about these 4 numbers? They're odd, but what else are they? They're all positive. If I'm going to end up with a 0, what do I have to have mixed in? I have to have some negatives. So the next thing I need to try has to be negative, because there's no way I can get a 0 if all my numbers are positive and I'm trying a positive number. So what do you want to try? Negative 1. So 1, negative 1, 4, negative 4, negative 1, 1. So negative 1 is no good. Alright, now what? Negative 5. So 1, negative 5, 0, 0, 3, negative 15. Do we like negative 5?
Yeah.
Yes. Okay? Now, here's the deal. I started with x to the 4th, and I have divided twice. So what does that mean is on this 1 right here? That's a square. Once you get down to a square, we want to write it down because we have 2 options once we get down to a square. What are our 2 options? We can factor it or solve it. Set it equal to 0 and solve. We can do one of those 2 things. In this case, since I'm dealing with a 3, I would recommend we set it equal to 0 and solve, but we should notice we run into an issue real quick. What is that issue we run into? It's negative, so that means it will not produce a real 0. What type of 0 does that produce? An imaginary 0 is what that produces. So this one right here only has 2 real roots, 2 real zeros, 2 rational zeros, which are 2 and negative 5. Okay? So this is not a hard concept. It can take a little bit of time if you're not a good guesser. If you're a good guesser, then you can run through it pretty quick. Okay? Now let's talk about a couple things. Okay, for instance, we started with 1 on the first one and figure out 1 did not work the first time through. Okay? If I try 1 again below that, will 1 ever work? No. Once it does not work, that means it will not work ever again on anything else you're doing. So keep that in mind. Once it's no good for the rest of the problem. Okay? So keep that in mind. All right, let's try another one. All right, so I'm looking at finding the zeros of this function. All right, so I look at 8. What are the possible factors of 8?
1, 2, 4.
1, 2, 4, and 8. But there's something different about this polynomial function than the first one I was dealing with. What's different about it? There's only 3 of them. There's only 3 possible ones. But the other thing is, I have a leading coefficient on my largest exponent. If you have a leading coefficient on your largest exponent, you have to take these over here and divide by those 2 or divide by the factors of that leading coefficient. Okay? So let me explain what's going on here. These top four, those are still possibilities. And remember, it can be plus or minus. When I divide by this, that means I now have the possibility of 1/3, 2/3, 4/3, and 8/3 as zeros. However, those can be plus or minus as well. However, when you do these problems, you should be able to find enough zeros from just the top. And if there are answers that are fractions, where are you going to find those? After you've divided and then you either factor or solve is where you'll get the fraction answers from. Okay? You should be able to get enough zeros out of the top to get you to where you can factor or solve to get any answers that are fractions. Does that make sense? So when you're trying, I only want you to try with the top number. Okay? Alright, so what do you guys want to give a shot on this one?
1.
1?
No.
Now 1, I probably wouldn't say 1 would work. Why would 1 not work? Yeah, this number right here, 22, is too big if I'm using 1. Okay? There's no way I can cancel out 22 if I'm using 1. So I wouldn't try 1. 4? Alright, let's try 4. So 3, 12, 5, 20, -2, -8. So we like 4. Okay? And notice I started with an x cubed, so what am I dealing with now? I'm dealing with an x squared. So this is x squared plus 5x minus 2. And what do I want to do to that? I want to factor it. So how do we want to factor that? Slide and divide. Okay, somebody read that for me.
Factors of 6, subtract to get 5.
Very good. Factors of 6 subtracted to get 5. So what are factors of 6 that will subtract to get 5? 6 and 1. Alright, somebody else besides Kaylee, read it the second time. Bobby.
The negative in front of the 6 says that the sign is different, and the plus sign in front of the 5 says that the biggest number is
Very good. Signs are different. Biggest number is positive. So I get a positive and a negative. And we need to remember when we do slide and divide to do what? Divide. Don't forget to divide. So that means I'm dealing with x plus 2 and 3x minus 1. So what are my other two zeros?
negative
1/3 and -2. Okay, I want you to notice the zeros we found. Are those up there? Are they one of the ones we said were possibilities?
2.
Yes. You've got the 4 and the 2 up top, and we've got the 1/3 right here, just like we said. Okay. We okay so far? Again, not a hard concept. You just gotta be a pretty good guesser to make it go quick. Last one. Okay, this one's set up a little bit different, but it still wants the same thing. It wants me to solve this equation, but when I'm solving an equation, what am I looking for, really? I'm looking for the zeros. So when I solve an equation that's set equal to 0, I'm looking for the zeros. Alright, so let's look at 18 first. What are my possibilities on 18? 1, 2, 3, 6, 9, 18. Then over here on the 6, we're dealing with 1, 2, 3, and 6. But again, we're just going to be looking at the top. We should be able to get enough answers from the top. Alright, so what do we want to get to go first time around? 3. So 6, 18, 31, 93, 61. I don't know about you, but I think that's going to be too big. So, again, do what I did right there. As soon as you can tell it's not going to work, save yourself some time, shut it down, move on to the next guess. Negative 3? So 6, negative 18, negative 5, 15, negative 17. That is 51. 51, which gives me 6, which gives me negative 18. So we do like negative 3. Okay. Now, can I eliminate any possibilities at this point?
18,
I can eliminate 18. I can eliminate 9. Does everybody see why I can eliminate 18 and 9? Because now I'm dealing with 6 instead of 18. So that means I can eliminate these two possibilities. Alright, so now what are we going to try?
2.
2? So 6, 12, 7, 14, negative 3, negative 6. We like 2 as well. And notice I started with x to the 4th. I have divided twice. So now what am I dealing with? I'm dealing with an x squared. Alright, so what do I want to do to that? Divide. So I get x squared plus 7x minus 18. I need somebody to read that for me. Carson.
Factors of 18 that subtract.
Very good. So what are those factors? 9 and 2. Good. Carson, read it through a second time for me.
The negative and the 18 says that there'll be different signs when there's a positive, so the highest one will be positive.
Very good. Excellent. Okay, and on slide and divide, don't forget to divide. Alright, so this reduces to 3 over 2, which makes it 2x plus 3. That reduces to 1 over 3, which makes it 3x minus 1. So our last two zeros are negative 3 halves and positive 1/3. Okay, are all of my zeros that I found in the possibilities up there? Yes. Because I've got 3 and 2 up there. 3 halves, I take the 3 over the 2. There's my 3 halves. I take the 1 over 3. There's my 1/3. Okay? So, that is using the rational root theorem to help find zeros in a polynomial function. Not hard, just can be time consuming. Just make sure you're paying attention. Alright, you have 6 problems for homework. Where'd they go?
Maybe 2. Thank you.
There we go.